anticipated by Gabriele, I'm going to provide you with some details. This study, it was a really huge study, so I'm afraid that although I want to give you an exhaustive overview, we have to run a little bit. First of all, the study about the transition to electric mobility in Burkina Faso focus on the identification of key enablers for the development of electric mobility. And detailed analysis were carried out for what concerns the technical performance, the financial performance, and the environmental performance of electric vehicles compared to conventional vehicle, internal combustion engine vehicles. The problems constituted by the initial investment, namely the purchase cost of electric vehicle, the availability of financing to purchase electric vehicles, the availability of charging network for vehicles, the capacity in terms of electricity supply in the two countries, and the overall policy support for this revolution, I would say. What concerns technical performance? So first of all, it should be clarified that the study, once again, was focusing on the 2 and the 3 wheelers. And the types of vehicles that we consider are those reported in these pictures. So we consider scooters, motorcycles, tricycles, and bicycles. And for what concerns the 2 and 3 wheelers in both the capital cities of Bamako and Ouagadougou, they constitute the main mode of transport for most of people. What concerns the technical performance of the electric models compared to internal combustion engine models, what can we say can be said is that both 2 and 3 wheelers have comparable performances in terms of technical capacities. Although for what concerns the 3 wheelers, it is more difficult to find models that can be satisfactory for what concerns the load capacity and for what concerns the maximum vehicle speed. This because 3-wheelers are mostly used to carry goods in urban environments. But overall, it can be said that especially for 2-wheelers, these models are competitive compared to internal combustion engines models. The financial performance was assessed through an analysis of the total cost of ownership. The total cost of ownership analysis compares the total cost supported by the users across the useful life of vehicles. So it was compared what is the overall cost of conventional vehicles compared to electric vehicles. And the main findings are that electric 2 and 3 wheelers generally present advantages compared to conventional vehicles that are linked mostly to lower consumptions. In this context, the main problem is constituted by the purchase cost of these vehicles. And we have to bear in mind that in most of developing countries, there is a very large part of the second-hand vehicles. So the comparison between the price of conventional vehicle with the price of new electric vehicles is really challenging. So prices of electric vehicles are much more high compared than conventional vehicles. By the way, the TCO analysis presented very interesting results. For example, here on the left side, it can be observed, the situation in the capital city of Bamako in Mali, while on the right side, the situation is related to the capital city of Ouagadougou. And this graph displays the differential in terms of total cost of ownership between the electric vehicles for the different models of vehicles, types of vehicles considered, and the traditional vehicles. So on the left side, can be said that for three-wheelers, the electric three-wheelers have 34% less cost compared to conventional vehicles. And for the three-wheelers cargo, the second type, the total cost is 43% less than conventional vehicles. The only models that at the moment present an higher cost compared to conventional vehicles are the tuk-tuk and the motorcycles, while for the scooters, electric scooters, they present minus 6%. So this means that electric vehicles, most of the models are profitable, are cheaper compared to conventional vehicles. This for Bamako on the left side. For what concerns Ouagadougou on the right side, all the electric vehicles present lower cost, total cost of ownership across their useful life. When we say total cost of ownership, the total cost includes the purchase cost and all the operational cost of running a vehicle. So it includes maintenance, it includes insurance, it includes all the costs like taxes, administrative taxes related to the ownership of vehicles. And if we have a more detailed look into the total cost of ownership composition, indeed, it can be seen that in both cities, for what concerns electric vehicles, the purchase cost is the most relevant category of cost. The purchase cost is reported in black. And the other categories of cost have a relative importance, and what creates the convenience in switching towards an electric vehicles is the energy and fuel consumption, because electric vehicles prove to be more efficient compared to conventional vehicles. So this is a further graph reporting a sort of a sensitivity analysis of the total cost of ownership. All the positive values indicate that electric vehicles are cheaper compared to conventional vehicles. And while the previous graphs that I showed were related to a range of about 9,000 kilometers per year, in this graph are reported the total cost of ownership related to different ranges of millages and millages. So from 5,000 kilometers per year till 55,000 kilometers per year. And this is the situation in Bamako, with some minor exceptions. All the models consider electric two-wheelers and electric three-wheelers show a convenience compared to conventional vehicles. And here in Ouagadougou, the situation is even better. So for what concerns the environmental performance, in the previous part of the analysis, the focus was on the financing, on the economic convenience. Here, the focus was on the environmental impact of electric vehicles compared to conventional ones. And electric two and three wheelers offer undoubtedly an opportunity to reduce the emission of CO2 equivalent during the life cycle of vehicles. And this assessment was indeed carried out through a life cycle analysis. And for what concerns Bamako, electric scooters present 83% lower CO2 equivalent emissions compared to conventional scooters, while this reduction for what concerns electric motorcycle is by 67%. Electric tricycles have 42% lower CO2 equivalent emissions compared to conventional vehicles. And in Ouagadougou, the situation is analogous. So the environmental impact from the production till the final stages, the dismantling of electric vehicles is something showing an environmental benefit compared to the use of traditional vehicles. But this is the situation more in detail. What concerns the emission of CO2 equivalent in both cities. And it can be observed that all the vehicles considered are linked to lower emissions than conventional vehicles, with the exception, of course, of the e-bikes. Why? Because the muscular bike is the most sustainable vehicles existing in the world. So it makes sense to shift to an e-bike if this implies the substitution of motorized vehicles. This for what concerns the environmental impact. And the comparison of the life cycle emission between the conventional vehicle and electric vehicles can be also showed having a look more in detail to the different phases of production, transport of the product, use of the product, and the end of life of the product. Again, electric models present lower CO2 emissions, and it can be seen that for what concerns the production of these vehicles, here the emissions are higher compared to conventional vehicles, but this is completely compensated by the phase of the use. When these vehicles are used, here it is achieved the greatest reduction for what concerns CO2 emissions. And again, this with the exception of e-bikes, if e-bikes are compared to muscular bikes, but again, it makes sense to compare them to motorized vehicles. The initial investment, as I said, this is related to the problem of purchasing electric vehicles. First of all, because so far, although electric vehicle prices are declining, they are on average higher compared to conventional vehicles. And in most developing countries, people do not perceive them as affordable because indeed the markets are dominated by second-hand vehicles with lower prices. But this is a problem because if it was possible to shift to electric vehicles, benefits would be achieved for what concerns the operation, because electric vehicles present lower consumptions in terms of energy compared to fuel and diesel consumption of conventional vehicles. So an issue here is that in Bamako, in Mali and Burkina Faso, there were no public incentives or financial programs to support users to purchase electric vehicles. So there were no policies in place to allow users to perceive as affordable from a financial point of view electric vehicles. So financing options, very, very few. So one of the main issues was constituted by the need of creating a financial ecosystem to support future users of electric mobility, and at the same time the need of identifying, for example, new business models and the financing the schemes such as a people subscription or rental models, battery subscriptions, and so on. And a promising option was identified, for example, in both cities in vehicle leasing, because this could have allowed to avoid the upfront cost, the very high upfront cost of purchasing an electric vehicle. And green financing options that are emerging all around the world undoubtedly constitutes an opportunity to be better explored. Charging infrastructure. Charging infrastructure is recognized in the literature and according to all practical experiences worldwide as probably the most influential factors for the adoption of electric mobility, because it is really, or at least influential as the purchase cost of electric vehicles, because users to switch to electric vehicles, and this was confirmed in both the cities investigated, Ouagadougou and Bamako, need to have the certainty of smooth and easy charging operations. Of course, the lack of a charging network is going to limit the large-scale penetration of electric 2 and 3-wheelers in the short, but also in the medium and long term. And for what concerns charging infrastructure, stakeholders interviewed expressed different opinions. Indeed, there were subjects more oriented towards the development of public charging infrastructure, for example, charging the poles on the road, and other subjects more interested in battery changing services, for example, services like the battery swapping. So the simple switch of discharged batteries with charged batteries, instead of spending the time at the charging poles to recharge the vehicle. And from a technical, regulatory, and economic point of view, it seems that an exchange service, at the moment, at least at the time we carried out the study, was a more feasible option in both cities instead of installing a charging station. This because of lower investment costs, at least theoretically. The electricity supply and the capacity of the electricity network, of course, is a crucial element to support the development. of electric mobility, and it was assessed what would be the impact in Mali and in Burkina Faso generated by the adoption of electric mobility, 2 and 3-wheelers electric vehicles. And what are the main findings? Changing the 5% of the current 2 and 3-wheelers fleet in both cities would consume something like 1.3 and 6.9% of the country's electricity production. A change of 70% would consume something like 19.5% and 82% of the country's electricity production. So this means that for sure, a large scale adoption of electric mobility, and here we are considering just the segment of 2 and 3-wheelers, would imply a stress for the electricity grid. So it is important to envisage proper investment to strengthen the electricity grid and to make electricity production more suitable for this kind of transition. And here are just reported some graphs where it was estimated the energy consumption in both cities. And the policy support. The policy support, we can say it is an overarching condition for the development of electric mobility. And for what concerns Mali and Burkina Faso, it was really a moment characterized by huge political instability. And this was an obstacle. This was identified as an obstacle for the development of electric mobility, but this is an obstacle for all the contexts characterized by a not stable political will and unstable political conditions. However, according to stakeholders, electric mobility can be perceived as an interesting and a positive revolution among citizens if the environmental benefits, first of all, if the environmental benefits are well communicated. And at the same time, positive messages could be also linked to the possibility, provided that people can buy electric vehicles through financing support. So positive message could be linked to the possibility to have benefits in terms of less consumption when using electric vehicles compared to conventional ones. The first part of the study was completed with the identification of potential pilot projects in both cities. For what concerns Mali and Burkina Faso, the beginning was identified the capital city of Ouagadougou, and later it was forecasted by the World Bank to identify also pilot projects for another city, that is Bobo Dioulasso. So, by the way, the pilot projects that are really important, that are key elements to allow citizens to make experience with e-mobility, were designed in the following way. It was proposed to deploy a pilot project with e-bikes for students and employees in the capital city of Ouagadougou, and while deploying electric moto taxi in the capital city of Bamako. And for both cities to deliver pilot projects deploying e-scooter for delivery services and e-scooter for public employees. I cannot provide details about now. this pilot project, but if you access the main report whose link was provided by Gabriele in the previous slides, you can read all the details, not all about this, of course, but about the entire study. The second part of the study was the phase 2, of the study was devoted to investigate cross-cutting issues. So while the first part of the study tried to understand what could be the potential of electric mobility, reconstructing the current state of mobility and the readiness, if we want, of the country to embrace this development or to support the development of electric mobility. In this second phase of the study, the focus was on some cross-cutting issues. The first of them was constituted by the possibility to have participation by the private sector in the electric mobility. And having a look at the international situation with the special attention to what is going on in Africa continent, in Africa, private initiatives, for example, on electric mobility are increasing, but once they are backed by suitable policies. And this was not happening in Burkina Faso and Mali, first of all, because there was no support by public policies. And by the way, through the engagement of stakeholders, besides the analysis of the conditions of the countries, it was quite clear that opportunities could arise in vehicle sales and in future mobility services, in battery manufacturing, charging infrastructure, and renewable energies. The sector of the renewable energies, for example, is one of the most promising, even because the benefits, the environmental benefits of electric mobility and switching to a technology like the electric one are linked to a proper electricity mix. So renewable energies are the fundamental element for a more sustainable mobility system in the future. And of course, so the main message is that policies and suitable regulatory framework, as well as awareness raising and information, should support electric mobility development. But what could be and what is the role in general of the private sector in the e-mobility as shown by international experience? Of course, there is a strict interaction between private sector and public sector, because on one end, public sector set up policies and set up a regulatory framework. So set up the general overarching conditions to enable investments, to enable private activities, to enable specific market dynamics. And the private sector is the main subject of what concerns manufacturing of electric vehicles, electric components, charging infrastructure, services related to mobility, not only electric one, but also electric mobility and the renewable electricity generation. So private sector and public sector show a cooperation that can take the form, for example, of public-private partnerships, especially for what concerns charging infrastructure development, but at the same time, what concerns pilot projects. Pilot projects, as I said, that are the first step into electric mobility to test technical, financial performance, and so on. So there are barriers hindering a fruitful cooperation between the two subjects that are financial barriers, regulatory barriers, and technical barriers. And this need to be overcome by the public sector. So a second cross-cutting issue was constituted by the job creation potential or the job destruction potential, because indeed electric transition in the countries would pose, as in the rest of the world, challenges in terms of investment displacement, I would say, and destruction of traditional jobs. But at the same time, there are opportunities in terms of creation of jobs linked to new activities provided by the electric mobility. And job opportunities in Burkina Faso and Mali could be linked to the deployment of a charging infrastructure and the operation of charging infrastructure, the development of the electricity sector in general, and as we said, the development of renewable, at the same time, the development of mobility services. For what concerns the battery manufacturing, this could be an opportunity linked to the long-term period. For what concerns the vehicle manufacturing, at the moment, it seems there is no potential to trigger an economic activity linked to this, but there is room to have economic activity linked to assembling of vehicles, and this is already the situation in other African countries. And of course, the job destruction, the threat in terms of job destruction in both countries linked to the end, let's say, of the market related to hydrocarbon sector and traditional maintenance activity. So here, the key message is that countries need to be prepared in terms of capacities, technical capacities, to accompany an eventual development of electric mobility. So, political economy. This section, these cross-cutting issues aimed at understanding what could be the different positions of the different stakeholder categories towards electric mobility. In general, in the Sahelian area, in Mali and Burkina Faso, there was no clear perception about electric mobility because there was no significant development of this kind of technology. But it was reconstructing, according to interviews to the main stakeholders, what could be the orientation of each category. So it was produced, for example, a graph on the left side reporting the potential support or the potential resistance or a neutral approach towards the deployment of electric vehicles by the different stakeholder categories. And for example, this is interesting, in the support area, for the government of both countries, but at the same time oil companies, because oil companies wants to catch the opportunity of new businesses related to electric mobility. At the same time, for example, electric development is also supported, of course, by electric companies, and financial institutions are somehow interested in. The graph on the right side link the power and the capacity of influence of each stakeholder and their interest in electric mobility. And it can be seen that government, oil company, financial institution, electric companies are the most influential, among the most influential stakeholders with a strong interest in this electric transition. So this was a useful exercise to understand how policies should react to the different position and interest of stakeholders to ensure a successful consensus building. The last part of the study, and these are the last slides, was related to fiscal implications. So electric transition creates also challenges in terms of stress for what concern the public budget, because public budget relies on revenues from taxes linked to conventional vehicles, for example, the fuel consumption, but not only that. And so we provided an overall estimation of the potential impact in fiscal terms of electric. And to do this, we created three different scenarios characterized by a market penetration of 10%, 25%, and 50%. And as electric mobility has shown a worldwide need some incentives or disincentives for conventional vehicles, we made some hypotheses about discount on electric 2- and 3-wheelers import, registration, and possession taxes. And for all the market penetration scenarios, it was estimated the impact according to 20%, 50%, or 10% discount on the previously mentioned taxes. And these are the findings what concern the reduction of revenues linked to fuel taxes. This would correspond to a reduction of 10 or 50% of the business as usual level. Business as usual is the current condition, you can say, that correspond to a reduction of the overall state revenues between 0.1% and 0.5%. This was the situation in Mali. The impact in Burkina Faso, still, what concerned fuel taxes, was included between 0.3% and 1.4% of the overall state revenues. And a similar impact assessment was carried out for taxes, reduction of taxes related to the import of vehicles. So I would like not to detail these numbers because it could be confusing, but the main message here is that for sure the fiscal impact would be significant, and this requires a restructuring of the overall tax system in the two countries, and at the same time a revision of the priorities in public budget spending. This is really important. And as the electricity, and this is a very last point, as the electricity production in both countries was subsidized, the transition towards electric mobility would also imply an increase of public subsidies. So this could be a further element of stress on public budget. Thank you so much.